Hello, what's up, right? Today you see me again, teacher Ed, and this is about the first time I'm going to record the videos about PAT exam, okay? Because we are done already with like the key concept, right? All the basics and those theory. So this topic is about this determinant and matrices, right? PAT1. So we're gonna start it from this year 2559, right? 2559 in March, right? We have this problem. The first one is number 26, okay? You're gonna have to do this one day in your exam, okay? With me or maybe not with me, okay? But anyway, first step, right? I made some mistakes and you have to fix this. Like you're gonna have to change this number 2 into number 1, right? I'm gonna do it fast a little bit, okay, today because I have to do something. Yeah, I have something to do actually. Okay, so what you have, like you have A inverse, you have B inverse, and this is what you have, right? This one, and A and B they are any real number. A is not zero, B is not zero, and this is the another information that you have, right? Another information you have, right? And the problem asks you to find this one, det of 2A plus B. You have to be careful, okay? This one is like a mistake of many students because when they see something like this, right? I don't know, like it's a kind of feeling that most of the student wants to do something like this. You know, right? They want to have det of 2A added with det of B, which is not okay. If you're trying to do that, you're gonna make a lot. You're gonna make mistake. So don't do it. Like determinant is distributable only in the product and the divisions. Okay, it's not okay to distribute it into the sum or the difference. Okay, so don't do it. Okay, I warned you already. So if you make a mistake, that's your fault. Okay, because I warned you already. So let's see, right? So you have this information. You know, right? When I read all the problems, I feel like this one is more like familiar. You know, right? It's like the first time when you go to the classroom and you see a lot of friends, like, and you want to be a good friend with somebody. When you look at him or at her and you feel good about it. So this is what I feel. This is the only thing that I feel like good about it because I feel like I can do something. I can do something and I can get something from it. Okay, so this one, right? I come back. I think that if I take this B out, right, I'll get this A inverse, A transpose inverse, right? To get this B out, I have to multiply with B inverse, right? I have to multiply B inverse to the back of this. And if I multiply B inverse to the back of this one, I have to multiply the same thing, like B inverse to the back of the thing that you have on the right hand side too. So this is B inverse that we have, right? This is B inverse that we have. So we're gonna do it now, right? So this one I'm gonna write A transpose something, right? A transpose and inverse, right? A transpose and inverse. Okay, my negative one is bad. Let me fix it. Okay, let me fix it. Okay, A transpose and then inverse outside. Okay, so if I multiply B inverse to the back, then this B and this B will be cancelled. So on the left hand side, I will just have like A transpose and inverse, right? On the right hand side, I'm gonna have this 8, -2, -3, and this one is I fixed it to 1, no more mistake, right? And multiplied it to this B inverse to the back. 1, 0, B and 1, right? So let's do it quickly, okay? Let's do it quickly because we want to get something out of it, right? So let's do it quickly. So the first one, right, the number that I get is going to be like 8 times 1 is 8, right? And then -2 times b is negative 2b, right? Next one is 0 and -2, so that's -2, right? Next one, -3 plus b, okay? -3 plus b. And then the last one is just 1, right? Just 1. Okay, so this is what we get, right? And when we come back to the left-hand side, we have this A transpose at inverse, right? But you know what? We have a property. If you watch my clip, right? I assume that you already watched my clip. You know what? All of the 7 clips will sharpen your knife. Okay, your knife is gonna be sharp. Okay, so this one works like this. It works like exponential number, right? If you have one number inside a bracket, another one is outside. You can swap them anytime you want. Okay, but and why do we have to swap it here, right? Why do we have to swap it? What is the reason? What's the reason behind this, right? We have to swap it because if you come back here, right? Here you have like A inverse, right? but you don't have A transpose. So if you want to do this step, it's impossible. But if you swap T and a negative one a little bit, right, it becomes, right, the impossible becomes possible now because you can find it. Okay, so I'm gonna let this one equal to A inverse transpose, right? That is my A inverse. So if I transpose it, I'm gonna have this one like A0 from the left to right is gonna be A0 from top down to the bottoms like this, and then this one negative 2 and 1, right? I'm gonna have to write it negative 2 1 like this from top down to the bottoms, and come back here. I see that if the two like matrices are equal, right? I taught you in the classroom if the two matrices are equal, they're gonna have to be equal like precision to precision, right? So we're gonna see that this one is going to be equal, right? The first precision 8 minus 2b is going to be equal to a, right? So we go a is equal to 8 minus 2b, something like this, right? The next one, right? Next one we go here, we have negative 2 equals negative 2. That is useless, right? 1 is equal to 1 is also useless, but here we have negative 3 plus b, and that's equal to 0, right? So you know from this one that your b cannot be anything else but 3, right? So you know that your b is 3 for sure. Okay, when your b is 3, right, you just have to put 3 back there into b, right? 3 back there into b. Then you will have like 8 minus 2 times 3, which is 6, and 8 minus 6 is 2. Okay, so your a is 2 and your b is 3 now. So let's go back to this original problem, right? This a is not a variable anymore, right? You bury it down. You change it into a number. You already right, kick it away. No problem. Okay, and this b is 3, right? So you can substitute there. You have a 3 there. Okay, and then what else now? What else now, right? What else now? What else now? When you have A inverse like this, you have B inverse like that, and you want to find is 2A plus B, right? 2A plus B. So you have to find A. If you have A inverse, you want to find A, right? So let's do it here. If you want to find A is going to be equal to your A inverse and inverse again, right? If you inverse it like 2 times, it comes back to be like the original, right? It has the same idea like when you do like negative or negative, like negative or negative is positive like that. So it's the same thing. Okay, so you want to get an A, right? You have to do this one. So you go 1 over if you remember the formula, right, you want to get the inverse, then you have to find 1 over the determinant of this one, right? So you go back there. A inverse is that one, right? So you have to find the det of it. Det is cross down minus cross up. So down is 2, up is 0. 2 minus 0 is 2. So I'm going to put here 1 over the determinant of A inverse is 1 over 2, right? And next one, I'm going to multiply into the adjoint matrix of it. To find the adjoint matrix, this one is so like simple. You just have to go back to this one and you swap this members, right? You have to swap the two members along the diagonal. So number 1 will just go up, number 2 will just go down, right? And then the numbers that are not along the diagonal, you just have to swap the signs of it. Swap the sign of it. Okay? So we say again like we swap the precisions if they are along the diagonal, but if they're not along the diagonal, we just have to swap the signs to be opposite. Negative would be positive, and positive would be negative. Okay, so this is my A now. Okay, I already have an A. I want to get a B, right? So I'm gonna do the same thing, right? If you want to get a B will just be like the same thing like A, right? The same thing like A. I just have to do B inverse twice. I just have to do like B inverse like twice, and it comes back to be B again. So let's do it. 1 over the det, right? We go there, right? The det is cross down minus cross up. So down is 1, up is 0. My det is 1. Okay. So next step, I'm gonna find the adjoint matrix of this B inverse, right? I'm gonna swap R. That is like we don't swap anything, so we just go like that. And then this 3 and 0, right? 3 and 0, we swap the sign of them, so it goes like that. Okay, so we're done with it now. Come back here. This is what you have to find for the problems, right? Det of 2a plus b. If you want to get 2a, right? So you'll come back to look at this. Aha, but you have an A. How do you get like A? How do you get it? How do you get like 2A? Right? So how to get 2A is just to multiply all of them with 2, and you're gonna get 2A. So when you multiplied it with 2, then the 2 and 2 just cancel, and your 2A is just the matrix without any like scalar in the front, right? So you want to find det of 2A plus B. So that will be equal to the det of the sum of this guy and this guy, right? So you want to find the sum of them. It goes like 1, 1 is 2, 0, 0 is 0, 2, negative 3 is negative 1, and 2 plus 1 is 3. You find the determinant of it, right? So cross down is 6, cross up is 0, down minus up, 6 minus 0 is 6. And that's your answer. Okay, that's your answer for problem 26, right? PAT1, March 59. Okay. So I wish that it's gonna be okay, right? Because we did it in a class like one time. We did it in the class one time already. I know that you know it. This is like a revisions again. In case that you have something in your mind that is not so clear, I can clear it out for you, right? Okay, so next number 39, right? Number 39, okay, number 39. This one, it's not so hard. Okay, so let's do it now, right? The problem gives you an A, right? An inverse, not inverse, sorry. The problem gives you a matrix A, and then it asks you to do something about A and A transpose to get 9i. I still remember, like in a classroom, like one of your friends came to me and he said, "Teacher, what is this? Is this like an L?" I would say like that's not an L. Okay, I'm so sorry. This is something that I hated so much because in Microsoft Word, right, when you write the I like this, it changes your font automatically into something like this. You know what? It's not an L. Somebody just say like, "Teacher, is that a slash?" No, this is not a slash. But what it is? What is it? It is this. It is this 3 by 3 identity matrix. All right. 3 by 3 identity matrix looks like this. 1, 1, 1 along the diagonal. The rest are all like 0. This is what we call a 3 by 3 identity matrix. Like this 3 is like the number of rows, and that 3 is the number of columns, and they are equal. Okay. This one we have like a squared minus b squared, right? Okay. This is what you have to find. So let's see. Let's see what can we do at here, right? So this a is already there, so we're just gonna write it down. Okay. We're just gonna write it out. We're gonna do the same thing like this one, like the thing that the problem asks you and me to find it. Okay. So let's write it down. A 2, negative 2, and 1. Okay. And then A, B, and 2. And this one is 1, 2, and 2. Right? This is our A. We're done with this one now. We're done with A now. So next one we're going to find A transpose, right? This one A transpose. It's so easy. You just have to swap the row, all the rows to be the columns. Okay, so we go 2, negative 2, 1, right? This row becomes a column now. The next one, like the second row, we change it to the columns. It is the column number 2, right? So this one 1, 2, 2 goes like this from top down to the bottom. Okay, and then it is equal to 9 times of I. So if I looks like this, 9 times of I would just go to be this 9, 9, and 9 along the diagonal, and then the rest are all like 0 like this. Okay, now let's come to the like matrices. Yeah, I say matrices like. Okay, so if I want to get A and B, right? I want to get A and B. I have to do something with it. I'm gonna do okay. Let me ask you, right? This one. If you multiply this one to this one, you will get for sure this number, right? You will get for sure this number 9, because number 9 is something that you get from row 1 multiplied with column number 1, right? But somehow it's something that is, it's not about A and B, right? So if you do, you just get a constant and waste of time. You don't get anything about A and B, so we're not gonna do it. Okay, we're smart. We're not gonna touch it. We just leave it. So I think that the smart choice for smart people, right? Smart teacher and student would just be this one. Okay, if you multiply this one, right? Row 1 and column number 2, you will get this, right? Row 1, column number 2 is here, 0, and then If you multiply, you are going to get like 2 times of A like this. Negative 2 times this one is negative 2B. 1 times 2 is plus 2. And that is equal to 0. So you just form like an equation number 1, right? You just form an equation number 1. Okay, which has something about A and B. That is like a smart way. Okay, not just a constant. Constant of nothing, right? Constant of nothing. Yeah, like it say, like constant doesn't change. So if you do it, you don't change anything too. Okay, so next one, right? I may want to go here, right? I go here, like to this second row, right? Because I'm done with the first row already. So I'm gonna multiply it with how about a third column? If I go, right? If I multiply this one, I'm gonna get the same thing like this, right? 2a minus 2b plus 2. So it's not a smart way. So I'm not gonna do this. I think I'm not gonna go to this one because I'm gonna have like a square, right? I'm gonna have like b square. I'm gonna have like 2 square, which is so hard like to get the answer. So I'm just gonna go to this third column, right? So second row times third column, we are going to get this one, right? Because this one is on the second row and the third column. So let's make an equation from it now. 8 times 1 is just 1, right? B times 2 is 2b, and 2 times 2 is 4, right? And I get it equal to 0. That is my equation number 2, right? That's my equation number 2. So now it comes back to like what you have seen before when you were in Matheum 3, right? System of linear equations. So let's solve it. If you want to solve it, you just go like this. Let me think for a while. I see this. Like negative 2b, and this is positive 2b. I know that I can eliminate b away. So I'm going to do this. I'm going to plus like 1 and 2, right? So I'm going to get like 3 times of a. And then this one is gone, right? No more b, okay? No more b's. B's are all gone. Like plus 6 and equal to 0. 3a plus 6 is 0. I can just do it in my mind. I don't have to write it down. That a is, of course, negative 2 for sure. 100% negative 2. Okay, then if I want to get my a, this a is easy to get. So I'm just going to substitute this. A equal to negative 2. No, I already get an A. I'm sorry. I don't want to get an A. So I have to put an A back there to get a B out, right? To get a B out. So let's substitute it back into the green color. So I'm gonna have A equals negative 2, right? And then plus like 2B plus like 2 times of B plus 4, and that's equal to 0. Okay, let's do the math a bit. Like my 2A and my 2B, right? This and this just cancel, like make it smaller down to number 2. So 2 times b plus 2 is 0. My b is automatically comes out to be negative 1. Nothing else but that. Okay, so let's go back. We already have the a and the b, so we just go back here. I find the value of this. Find the value of this. A squared minus b squared. So it's going to be equal to our a, which is negative 2 squared, minus our b, which is negative 1, right? And then we square it up, so it comes out to be 4 minus 1, and 4 minus 1 is 3. Yeah! So that is the answer. That's the answer. If you don't understand it, you let me know, okay? Because I'm going to go back to see you on Tuesday. Alright? I'm going to go back to see you on Tuesday. I'm going to go back to see you on Thursday. I'm going to go back to see you on Friday. Okay. Hey, next one, right? So you see, right, in a year, right? This is year 2558 now. So I would just say in a year that you have to take the PAT exam, you may have to do about like 2 problems about metrics and determinant. Okay. That's it. Okay. So from the statistic, it shows that. Okay, this problem, I make a mistake again. Right? I forget to put an equal sign there in front of negative 24. So you just put it there. This problem, you have this matrix A, you have this matrix B, and then you have this information. A, B, C, and D, they are the members of all positive real numbers. Okay, so all of them are not negative. They are all positive. Okay. And then you have this one more information, like the products of all of them is 9. Okay, product of all of them. All of them are positive, and you multiply all of them, you get a 9. Okay, AD is not equal to BC. Okay, this is a useful information. This one is, I don't know it. You just have to find more clue of it. This one, we come back, okay, A times B inverse is equal to B inverse times A, okay, something like, you can swap the place, right? This one is like swappable, something like swappable, okay. And then this one, det of A transpose times B is equal to negative 24. Aha! I see that I have an A, right? I see that I have an A, so, and this one, right, like I told you in the problem number 1, right, if you have a det in front of the product like this, you can just distribute, right? You can just distribute or expand, okay? We just call it distribute the expand. I'm not sure, right? But this one is like a property, so you can have like this det of A transpose multiplying with det B, and it's gonna be equal to negative 24, something like this. You know what? This one looks like most friendly. This one looks most friendly, so we're gonna start it here, right? Okay, so here we have det of A transpose. If you are a good student and you have watched all the videos, then you should know that we have a property. So we have a property that det of A transpose is exactly equal to det of A. So we can just find det of A for det A transpose. So det of A is down is 1, up is 4, right? So down minus up is negative 4, negative 3, right? So we're gonna have this one equal to negative 3. And then you just have to think of it in your mind. Negative 3 times det B is negative 24. So nothing else that det B can be except an 8, right? Except an 8. So det B is an 8, okay? Det B is an 8. I'm gonna put it in the box so that we can just use it like later. Okay, let's see. Okay, go back there, right? We have our B there. If you want to find det B, right? We can just like find more information about det B, right? Det B is like just one word, like that one word. We want to find more clue of it, right? So det B, if we do the math, it's like down minus up, right? So it's like this one is like AD and then minus with BC like this. Right? If we do the math, right? If we get into it, and then you just want to do something about that, so that is what we have. Okay. So I have like another like information like this: 8D minus BC is 8. So I think the next train that I want to talk with would be this information. Okay, this information, right? We did this one already. That is the first base friend. Okay, this one becomes our best friend already. Like this one is a guy that is like, I don't know, good looking, so we just want to talk to him, okay, because he has AD and he has BC, right? Okay, so we're gonna do this. We're gonna do this. All right, we're gonna do this. We know that if we group a bit, right? If we group a bit, we can have like AD times BC, and they will be equal to 9, right? So I'm gonna write it now, right? Group it something like A and D, group it together like this, and then BC like this, group together, and then the product of them is 9. So yeah, the product of them is 9. And then I come back to this one, right? I see that if I move this negative BC to the left, right, I will have like 8 plus BC equals to AD. So I'm gonna substitute it here, right? 8 plus BC, right? This one, okay, if I just rearrange a little bit, I'm gonna have AD is equal to 8 plus BC like this. So from this information, I know that I can replace this AD to something about BC, right? I can write it in terms of BC like this, and if I multiply, I'm gonna get BC out. So this BC, maybe I'm gonna let my BC equal to X. Okay, let BC equal to X like this. BC equal to X. So this one looks like 8 plus something like, if this one is not an X, right? This one is not an X. So I'm gonna multiply my X, this X into it now. So I'm gonna have like 8X plus X squared equal to 9, right? So let's move them to the same side. So I'm gonna have X squared plus 8X minus 9 and equal to 0. It is equal to 0, something like this. Then let's do the simple factorizations, right? Simple factorization. So let's put okay, sorry. Let's put an x here. Let's put another x here. Something that multiplying up to 9 and have the sum of 8. I don't think of something else except 9 1 plus at 9 and minus at 1, right? Because they have the product of negative 9 and the sum of them, right, is equal to 8. So I know that mine x is going to be equal to negative 9 and 1, right? And I know that x is equal to bc, so this x is exactly equal to bc, right? So now my bc is negative 9 and 1, right? Negative 9 and 1. Okay. So now it's time to play a game about like good cop, bad cops now. You know, like good cop, bad cops. Okay. One is like a thief but wearing a cop uniform, and one is a real good cop. So this one, right? B times C is negative 9. Okay, but if we go back there, right? You see, right? All of them are positive, right? All of them are positive. A, B, C, and all of them are positive. But you come back to see this. Hey, B is positive. C is also positive. So where the hell on earth that you get the product of them equal to negative 9, right? So you know exactly that this one is a bad cop. This one is a bad cop. This one is a thief. Kill him, right? Kill him. But this number 1 is possible because positive times positive can be positive. So this is a good cop. So you keep him. Okay, number 1 is good cop. Okay, you keep him. Okay, so now when you have BC equals to 1, right? You go back there. Hey, BC is equal to 1 now. Then you know exactly that AD is gonna be equal to 9, right? Aha! Okay, so AD is 9, A times D is 9, B times C is 1. And then you're gonna have to find this, right? The sum of A, B, C, and D's. So you don't have any other choices except to break it out. To break BC out into something and AD out into something like 2 numbers. So we still have this one left, right? This one. We still have this one left. Okay, let's go to this one. So, because I know that to find inverse, right? You look at this one, right? B is like this, A, B, C, and D is like this. If I want to find an inverse of B, it's not going to be easy. I'm going to do something about like 1 over the determinant and multiply with the adjoint matrix, right? I don't want to do that. So, what should I do, right? What should I do? So, I'm going to do something like this. I'm going to apply some properties. So I feel like, now I hate B inverse so bad. I hate B inverse so bad. B inverse, you are like somebody who killed my dog, okay? I don't want to talk to you. So, if I want to get rid of this B inverse, then I will just have to multiply a B, right, to the back of it. Then bye-bye B inverse, you are gone. I don't want to see you, right? But if I multiply B to the back, I have to multiply this B to the back as well, right? So that the equation will be like balanced. Nothing is wrong. Okay, so now I have this A equal to B inverse times A times B. B inverse is still here. Come on, man. You killed my dog. I don't want to talk to you. Bye-bye, right? I'm going to ask John Wick to kill you. So John Wick will just come and multiply you with another B in front like this. You know, right? Bye-bye. BB. So you're going to have B times A equal to A times B now. Okay. Which is like an information about BA and AB. And it doesn't, you know, have anything about B inverse and A inverse, which is like a problem. Okay. So what can we do there? What can we do there? So I'm gonna take you down to some space on this right hand side, right? Because we have like B times A equal to A times B. So I'm gonna do like this. Okay, I'm gonna do like this. B times A. No. This one will be a block of, okay, B times A, and this one is gonna be a block of A times B, right? A times B. Okay, so I'm gonna do it now. So let's go back there, right? Let's go back there. This is our A and that is our B, right? So let's find the first one, right? Let's find the first element here. The first element here is going to be the result of this, right? 1 times A plus 2 times C. That is like A plus 2C. A plus 2C. So this is BA. No, I'm sorry. BA. No, because I just did like AB, right? So I'm gonna have to write it here, not on the left, but on the right. 2A and then plus C cat. Okay, I write it correct. This is mine A times B. Okay. I mean like first row of A times the first column of B, right? So um, this one, right? I want to get B times A, so I'll just go back there. Right? B times A. This B has row number 1, like AB. I'm gonna multiply it to the first column of it, right? So let's go. A times 1 is a 1. 2 times B is B times 2 is 2B. So I'm gonna write A plus 2B. Okay. So the first position is now equal to the first position. I see that. Now I make a mistake or not? A 2A plus B, right? Yeah, I think I make a mistake. Wait a bit. Whoop, AC correct. And if I do this, AB times this, right? A plus 2B. Huh? A plus 2B. And this one, how about this one? Row. Hmm? A, B, C, D. Row 1. Row 1, column 1. So it go like A plus 2C, that's correct. And then BA, it's gonna be row 1. A plus 2B. Okay, that's correct. So what is wrong with me? Okay, BA is equal to AB. Hey, something is not okay, right? Something is not okay or not. A times B, right? A times B, 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 1 times A is A, 2 times Z is 2Z. Ah, stupid me. I'm gonna have to write this one, okay? I'm sorry, because I made a mistake. Okay, I made a mistake. So it should be like this, okay? Just waste your time, sorry. It should be like, you know, A times B should be like A plus 2C, not 2A plus C. It should be like A plus 2C. And this one, like B times A, is gonna be A plus 2B. A plus 2B, like this. Okay, sorry. So now when they are equal like this, right? I know this is equal to that, right? So we can just cancel. 2 can be canceled away. So I have B is equal to C, alright? I have B is equal to C. So I have this B is equal to C. This B is this B going to be equal to C. Okay, so we come back here, right? I know that this B is positive and this C is also positive, right? They are both positive. So positive times positive and have positive 1. I have nothing else except I know that B has to be number 1, right? And C has to be number 1. You know, right? Because you have the product of 1. You have the product of 1. Okay, so next one. Next one. I'm gonna go to find this one now, the second member, right? The second member. So I'm gonna start with A times B, second member of A times B, right? So this one is gonna be first row multiply with the second column. So I'm gonna have like B plus 2 times of D. So B plus 2 times of D. So I'm gonna come back for B times A. So I go like this, multiplying that first and the second. So it's gonna be 2A plus B. 2A plus B. Okay, this member is equal to that member. So B and B cancel, bye bye. 2 and 2 cancel again. So I have this A equal to D dot. A is equal to D dot, right? And I know from this information, all of them are positive. So A is positive, D is also positive. If we multiply this and we have positive number, then I have no other choices except A is 3 and D is 3. You know, right? Because we have the product of 9. This is positive. This is also positive. No other options. So we're going to have this 3, 1, 1, and 3. And we're going to have to find the sum of them, right? We're going to have to find the value of the sum of them. So that's going to be an 8. And that is your answer. Okay. So that is your answer. We have an 8 now. We have an 8 now. Oh, I talk like rapper now today. Very fast. Okay, number 36, right? This number 36. If you want to do it, I suggest that you should go to watch my video clip number 7. Okay, it's about column and row, the column and row like operations. Okay, the column and row operations. And I'm so sorry, I make a mistake a little bit. Okay, at first I want to have the determinant, right? So I should write it like this, but it's so small at here. I don't see that it has a small lake coming out there, right? I want to write something looks like the absolute like this. Okay. Okay, so just want to tell you that this det is equal to negative 17. Det of this metric is negative 17, and I asked you to find a determinant of this one. Okay, so we can do this. We can do this. If you don't understand it, go to watch clip number 7. Okay. So do you see the same thing that I'm seeing? Like I'm seeing this, right? I'm seeing this. I'm seeing this. I see that I have this third row of 5a negative a, right? And I have that third column of 5a negative a too. So what do I do, right? You know, right? The key thing is you're gonna have to change this. You're gonna have to change this original into this like transform like matrix. Okay. So my first step, right? I'm gonna change this one into something like this. I'm gonna change it to the transform, okay? And that transform transpose. So my first step, I'm gonna transpose this one into, okay. I'm gonna change it back to this blue color. I'm gonna not transpose this one into 1 B 0 like this, and then A for 1, and then 5 A negative A. You know, right? So now I have this third column equal, not just equal. I would just say like exactly the same as this one. And the determinant doesn't change, right? The determinant doesn't change because you know that we have a property like that A is equal to that of A inverse. No, that A is equal to that A transpose like this, right? So I transpose this, I have this column to be exactly the same as this one, but my debt is still the same. Okay. So next step, right? Next step. Now we can come to the next step. Okay. So next step, I just gonna have to look at this, right? So at the end, right, we expect to have this B in the middle and A in the front, right? B in the middle and A in the front. But if you come here, right, you see that A is in the middle and B is in the front, right? So what do you want to do, right? You just want to swap this, all right? You just want to swap the column number 1 and column number 2, right? Yeah, so we're just gonna go like this. C12. You know, right? When we write the symbol C12, it means that you have to swap column number 1 and column number 2. Okay, so let's swap it now. So my 1BO will just go to the middle. A41 will just come to the front. Like we have A4 and 1 like this, and then this one doesn't change, so it stays the same. Right? It stays the same like this. So if you do this process like of swapping the two columns, adding like two columns in the matrix, your determinant will just come out to be in the opposite signs, okay, you know, in the opposite sign. I I I don't want to prove it, okay. I think that I don't want to have I don't have to prove it because I already proved it in front of the classroom. Maybe if you want to ask me to prove it, maybe come to ask me later, okay. Aha. Okay, so after one, two, like 1, 2, 3, 3 steps, like we have this one now. And you look at this. Hey, at the end, right? You expect to have like 2 times it here, 2, like 2B and 0, and you come back here, right? So number 2 is like 2 times a 1. Number 2, not like 2B is like 2 times a B, and 0 is equal to 0. So what do you want to do, right? If I were you, I'm gonna do this 2 times of C2. You know what? I'm gonna multiply, right, mine second column with number 2 in order to have this 2, right, and 2B and have a 0, right? Because I want to do it like this so that this is nearer to be like at the end, right? This is nearer to be like this matrix at the end. Okay, so find A negative A is the same. Okay, And then we come back to look at this, right? We have a for 1 here. We have not a for 1, but it's like 2a, 4, and then 2. So if you look at this, right, 2a, 8, 2, they are 2 times of this, right? They are 2 times of these columns, right? They are 2 times of this column, like 2a, 8, 2 is like 2 times of this, this, and this. So I'm gonna do this in the same step, in the same like process. I don't want to write it again. I want to save the time. So I was just multiplying 2 to C1. I'm gonna have this like 2a. I'm gonna have an 8, and I'm gonna have a 2. So this metric is now closer to be like this one now. It's closer, but it's not yet exactly the same, right? So I multiply 2 to it. I multiply another 2 to it. Like so, 2 times 2 is like 4. So when you do something like this, it's like you multiplying a 4 to to the determinant, right? So your debt is gonna be like bigger by like 4 times. So 4 times of 17 is 68 now. So you have 68. Okay. And then okay, make a partition a bit. Next step, I already have this one and this one, like this row, this column and this column become like exactly the same, like this and this. But this is the only difference that we have, right? So if I want to change this 2a to be 2a plus 5, I think that I'm gonna have to add it with this one, right? Because I have a 5 there. If I want to get 8 plus a, I think 8 plus a is like this. This 8 from the first column will be plus with the a from the third column. Okay, so save the time. I just want to do this C1 plus C3. Okay, C1 plus C3, right? So I'm gonna have this. Okay, let's free it from the back so that it's not gonna be like too narrow. So I'm gonna have this 2a out of 5 plus 2a now, right? If I add this and this, I have like 5 plus 2a. I add 8 and this, I have this 8 plus a now. I add this and this, I have 2 minus a now. So my first column is now exactly the same as this one, right? Okay, so it goes 2 times the b, and 0, 5a, and negative a, right? 5 and negative 8. And that is equal to 68. Aha! So there is one of the properties. If you watch clip number 7, it says if you add any column of matrix with the other column of a matrix, determinant doesn't change. Okay, determinant doesn't change. So, okay, so that's your answer. That's your answer. Chip, chip, chip. Okay, I have done this video record for like 43 minutes now. I think that's gonna stop it here because if it takes too long, then maybe you are too tired like this. So I'm gonna stop it at here. Okay, I'm gonna stop it at here, and then when I find some more time, I'm gonna come back to do part 2 of it. So this one's gonna be like part 1, part 1. Okay. Okay. So everyone, good luck. This is Teacher Ed, and I will never leave you. I will always do anything that is good for you. Okay, without tiring. Okay, without tiring. Okay, so people, have a good day. Have a good day. I have to go now. Bye bye.